G'day again, back for question 11. So this one, find the integral of sine squared x dx. It's worth 2 marks, so you can't just give a straight definition and give the answer. What you need to do is work through the answer from your definitions. So from your definitions, you should know cos 2x equals cos squared x minus sine squared x, and you need to start from there. And the reason is, and I'll show you why. Let's say you assume that is just the integral of sine x squared, okay, and you assume it's just like an x. So raise it to a power, new power underneath, and that would give you sine x cubed all over 3. Differentiate that and you get cos x, put cos x in front underneath and we get 3 cos x. So this is going to simplify, plus c, so that would simplify to 1/3 tan x sine squared x plus c. And now if you differentiate that and try and get back to that, you can't get back there because this isn't the correct way to do it, okay? So you can't just do that sort of thing, it doesn't work. So you don't want to do that. You want to start from here, okay? So cos 2x equals this, and then you simplify this, so you've only got sine squared x, substitute it in, and then it's quite simple. So we'll just wipe that out. And so we'll translate cos squared x into 1 minus sine squared x. So that's 2 of them. Now I'm going to switch those 2 over. So I'm going to get 2 sine squared x equals 1 minus cos 2x. Now I'm going to divide by 2. And now I'm going to put that in there. And again, we haven't got that, but that's not going to work. It's sine squared x. So we're going to put that in there, and it'll work quite easily. So we're going to have integral of 1/2 minus 1/2 cos 2x dx. Integrate that, and it's pretty straightforward. Integrate 1/2, and you get x on 2. Integrate cos x, and you get sine x. So we're going to get minus, I'll leave the 1 there for a minute, cos 2x, oops, sine, that should be sine, shouldn't it? Sine 2x plus c. So when you integrate this, that's another function, so differentiate that, put it in front underneath, so it's 1/2 multiplied by another 1/2, which is 1/4, and you're done. Okay, again, 11b. Calculate the size of the acute angle between the lines y equals 2x plus 5 and y equals 4 minus 3x. So this is question 11b. Should be pretty straightforward. You just need your angle formula. So tan theta equals m1 minus m2 over 1 plus m1 m2. And they're all your gradients. It's pretty easy because they give the gradients to you. That one's 2 and that one's minus 3. Plug them in here, press your calculator, and you're done. So 2 minus 3 all over 1 minus or plus 2 multiplied by minus 3. Absolute value. 2 plus 3 is 5. 1 plus minus 6 is minus 5. Take the absolute value and you get 1. Shift tan 1 on your calculator and you get either 45 degrees or pi and 4, and you're done. G'day again, 11c. Solve the inequality 4 over x plus 3 is greater than or equal to 1. Again, we're on question 11, pretty straightforward. First thing I'll do, look at that and say, what can't x be? Well, x can't be minus 3. So that would be my first statement. X cannot equal minus 3. Next thing I do is draw a quick quick number line and put minus 3 on it. Notice I put a 0, or a circle, can't be equal to minus 3. That helps you answer the question a bit later on. Now I just solve it the same as any typical algebra question. So 4 greater than or equal to multiplied by x plus 3, take 3 off. And x is less than or equal to 1. So put it back on your number line. Put an arrow because you know it's that way. Now because it's extension 1, don't just rely on the fact that you've done that. Check here as well, because you never know. It could mean back here, so just pick a number. So let's pick minus 10. So we'll go 4 over minus 10 plus 3 greater than or equal to 1. Well, this is clearly not going to be greater than 1 because it's going to be negative. So this is clearly false. Okay, so if that's false, that means this is false. That means that is definitely your answer. So you just write that as an answer. So you've got minus 3, x is here, and then you've got 1. So it can equal 1, can't equal minus 3. That's your answer and you're done. G'day again, 11D. Express 5 cos x minus 12 sine x in the form a cos x plus alpha, where alpha is in between 0 and pi on 2. So for this one, what you need to remember is the position of these two in a triangle. So if you look at a right angled triangle, and there's alpha, putting these two in the right position is really important. A thought is, if you think of sine as the side, so this is the side, so that's going to be 12 and the 5 is going to go on the bottom. So that's going on the side. Maybe that'll help you remember where to put things. This squared plus this squared is going to be your A. So that squared plus that squared square rooted will be that position of A. So you should know that if you square root 5 squared plus 12 squared, you get 169. Square root of 169 is 13. So this is going to be that A. Okay, so you'll have 13 cos something or other. This alpha is important in knowing that you've got 12 on 5 for your tan. So tan alpha equals 12 on 5. Because this doesn't work out to 30 or 60 or some nice number where you can say, well, you know, it's 3 pi on 4 or something like that, you can simply use this as part of your answer. So alpha equals tan to the minus 1, 12 on 5. And that is your alpha, and you know that is in between 0 and 90 degrees because it's, you know, it's part of a triangle. It's not obviously the 90 degrees. So then your answer will be x plus 10 to the minus 1, 12 on 5. Looks a bit weird, but that's it. And you're done. G'day again, 11E. So for a question 11, this one actually becomes quite tricky. Use the substitution u equals 2x minus 1 to evaluate the integral of x over 2x minus 1 all squared in between 2 and 1. So you obviously need to start with the substitution, but having given this to you, you'll see that the use of the half and the 2, unless you're paying attention and you do it carefully, you can really lose a mark very easily. So let's have a go. U equals 2x minus 1, du equals 2 dx. You will have to use this again because you've got an x on top and that's only a 2. So let's reorganise this. So we now have 2x, add that, so you're going to u plus 1. So therefore x equals a half 1 plus u. So we want this bit, and this bit, okay? And I think this can throw students off if you've left that in your working, you're looking up at that and think you can change it. So let's change it so we can actually move things into it. So we've got x dx over 2x minus 1 squared. Well, what we want up here is we want 2 dx, and we haven't got 2 dx, so let's put a 2 there and a half out the front to cancel that out. And then we're going to change the x into a half 1 plus u. Well, there should be a bracket there, shouldn't there? Okay, so let's go and do that. So then we're leaving this here because we want 2 dx to be du. So that's our du, which is fine. Now we're just dealing with the x. So 1 plus u is on top, and we've got a half. Well, we want that half, we're just going to pull that out the front. So that turns into a quarter. On the bottom we've got u squared. Okay, so that 2 and that half can get a little confusing, especially if you're writing down your working. Once you're here, it's not so bad. Now notice I haven't put in the values here of 1 and 2 because they're not valid, and they won't be valid until I get the x's back in there. You can translate them, and some people do that. They want to have, so here I've got 1 and 2, and here I'm not going to put them in, and I won't put them back in until later on. So let's integrate that. You'd split these up quite obviously. 1 over u squared, so we're going to have 1 quarter, integrate 1 over u squared plus u over u squared is just 1 over u du. Well, that one's obviously going to become a log. So 1 over u squared is u to the minus 2. Raise that to a power, new power underneath, so we get a quarter. So this will become u to the minus 1, so if you rewrite that, and that's u to the minus 2, and we just forget about looking at this and we concentrate on looking at this. Raise it to a power, we get u to the minus 1. New power underneath is negative 1, so let's just put the negative there. Plus, this is going to be a log u. Okay, so now I'm going to substitute back in, and notice again I haven't put down the values of 2 and 1 because they're still not valid. So now I'm going to put down 1 quarter minus 1 over, and we've got 2x minus 1 plus log 2x minus 1. And now I'm going to put in 2 and 1 because now they're valid. Now I want to put them into the x. So we're going to get a quarter, put in 2, 2 times 2 is 4, 4 take away 1 is 3, so we're going to get minus 1/3 plus 2 times 2 is 4, take away 1 is 3, is log 3. So we want that. Minus, put in 1 now. 2 take away 1 is 1, so this is minus 1. Minus 1 over 1. Put in 2, put in 1. 2 times 1, take away 1 is just log 1. Hopefully by now you know what log 1 is. Log 1 is 0, so that's gone. So then we've got minus 1/3 plus 1. So minus 1/3 plus 1 is 2/3. So I'm going to have a quarter times 2/3 plus log 3. And you could take it another step. A quarter times 2/3 is like 2 over 12 or 1 over 6. And then just a quarter log 3. And you're done. G'day again, 11F. Consider the polynomials px equals x cubed minus kx squared plus 5x plus 12 and ax equals x minus 3. Given that px is divisible by ax, show that k equals 6. Well, this one's pretty straightforward if you realise if that divides into that obviously 3 must be the root. So you can just put the value of 3 into there and make it equal to 0. So let's do that. So part 1, we're going to get 3 cubed minus k, 3 squared, plus 5 times 3 plus 12 is going to equal 0. Expand that out. 27 minus 9k plus 15 plus 12 equals 0. So 27 plus 15 plus 12, well that's 27 plus 27 is 54. 54 is going to equal 9k. So we're going to have 9k equal to 54, and you should know your times tables by now. 54 divided by 9, so k equals 6. So that should be a pretty straightforward, easy 1 mark, I hope. Part 2, find all the zeros of px when k equals 6. So for this one, you should have learned division. So effectively what you're going to do now is a long division. I don't know any other way to get this into that other than to do it by long division. It's not a very popular way, but it's the only way that I know actually to solve this question here. So let's do the long division. So you're going to have x minus 3 and divide that into x cubed minus, now we know k is 6, minus 6x squared plus 5x plus 12. We're just going to do a long division all the way down. So x is into x cubed goes x squared times. X squared multiplied by both of these is x cubed minus 3x squared. Subtract, put a line, that take away that, 0. Minus 6 minus minus, which is a plus, 3x squared. We're still going to have a negative 3x squared. Bring down the next one, 5x. How many times does, what are you doing? How many times does x go into minus 3x squared? Well, minus 3x. So minus 3x, I'm going to multiply that by all of this, so one at a time. Minus 3 times that must give minus 3x, whoops, squared. So ideally we're wiping out these things. If you've never done it before, that's what you're doing. You're wiping out each of these terms one by one. Minus 3x times minus 3, minus times a minus is a plus, 9x, put a big minus sign. You can bring down the 12 each time and just keep the whole lot of them, it doesn't really matter. So we'll bring it down there, but it doesn't really matter because it's going to keep going down. That's 0 obviously. 5 minus 9 is minus 4x plus 12. Now again we look, how many times does x go into minus 4x? Well, what do you multiply that by? Minus 4. So minus 4 times that is minus 4x. Minus 4 times minus 3 is plus 12, and that's 0. So this is our quadratic. You can factorise that quite easily. So let's factorise that to give our other two factors. So if we factorise this, and we're running out of space, but we can do it very simply just here. So we're going to have x and 4 and 1. 4 times 1 is 4. 4 take away 1 is 3. That's a negative, so that will be a negative, and that will be a positive. So that'll be minus 4x plus 1 is minus 3x. So that's our factors. So our three factors are x minus 3, x plus 1, and x minus 4. Right, so they're all our factors. So our zeros, so therefore zeros, x equals 3, minus 1, and 4. And you're done.